Descriptive mineralogy. Coming to the quartz group of minerals. So coming to the silica and the varieties, the different varieties of the silica are classified into three groups. They are number 1, crystalline variety, number 2, cryptocrystalline variety, and number 3, amorphous variety. So coming to the crystalline variety of silica, so there are again three types of important crystalline varieties of silica. They are quartz, tridymite, cristobalite, and stishovite and coesite. So coming to the quartz group of minerals, quartz is an important rock forming mineral. It is found in all types of the rocks, and chemically this quartz is represented as SiO2. So there are trimorphous forms of the same chemical substance, or you can say that polymorphic forms also. So suppose if we take quartz, it is hexagonal, and tridymite, it is colorless or white, and it belongs to orthorhombic system, and this has the stable form of a silica in between the temperatures of about 870 degrees centigrade and 1470 degrees centigrade. So this tridymite, it occurs in certain acid volcanic rocks. Another crystalline variety of silica, that is a cristobalite. It is a stable form of silica above 1470 degrees, and it belongs to cubic system, and it occurs as minute octahedrons or cubes in lavas. Another variety, that is known as stishovite and coesite. So these are the high pressure forms of silica, and they have much higher densities and refractive index than the other polymorphs like tridymite and cristobalite. So here the stishovite, it is the only polymorph where here the silica, it occurs in six-fold coordination with oxygen, and this occurs due to high pressure under which the mineral forms. Both stishovite and coesite, they have been found associated with the meteoritic impact structure. So meteorite means any extraterrestrial metal which hit the earth is known as a meteorite, and here the stishovite and the coesite, they are associated with this meteoritic impact structures. Coming to the physical properties of quartz. So here the chemical composition is SiO2, and it belongs to hexagonal system, and you can see the excellent crystals, and these crystals, they show prismatic, rhombohedral and trapezohedral faces, and these are massive and also granular. Coming to the color, it is when it is pure, the quartz, it exhibits colorless, but due to the presence of impurities, as I have discussed in the colors aspect in the physical properties of minerals, so the mineral may show different colors due to so many reasons. Yellow, green, brown, red, black, and others can also be seen. So many colors, they disappear on heating. So coming to the streak, so streak of the quartz, it is uncolored, and it shows vitreous luster, as most of the quartz group of minerals, they possess vitreous luster. And if you take the cleavage, we cannot see the cleavage in quartz. So that's why here cleavage is absent. And hardness, so in the Mohs scale of hardness, this has a 7 hardness, and tenacity, brittle, and generally, so this quartz is unaltered, and it has a refractive index of 1.55. So here you can see the polymorphic forms of SiO2, quartz, tridymite, cristobalite, stishovite, and coesite. So here if we say quartz is hexagonal, and tridymite is orthorhombic, and cristobalite belongs to cubic system, and stishovite belongs to tetragonal system. So here you can see the name of the mineral, and it's a crystal system, and it has a density and refractive index. Suppose if we take a stishovite, it has a tetragonal system, and it has a density of 4.35, and it has highest refractive index of 1.81. Just now we have discussed that the refractive index of these stishovite and coesite are high when compared to the other minerals. And coesite, it is monoclinic, and it has a density of 3.01 and refractive index 1.59, and so on. So suppose if you take alpha quartz, beta quartz, low alpha tridymite, high beta tridymite, so low alpha cristobalite and high beta cristobalite, like that, these are the densities and refractive index of these minerals. Coming to the varieties of the quartz, there are different varieties. Like if you see the rock crystal, it is the purest and most transparent form of the quartz, and here you can see the excellent crystals, these are also common. And if you see amethyst, it is a transparent and purple in color. And if you take a rose quartz, this is a pink, or as the name itself indicates that it is pink or rose red in color. And if you take a smoky quartz, it is smoky yellow to dark brown, and it is often called as a cairngorm stone. And another black variety of quartz is known as a Morian. And if you take the transparent quartz, It is colorless and transparent, and it shows typical conchoidal fracture and vitreous luster. The another type of varieties, like if you see milky quartz, it is milky white in color, and citrine, it is a variety of the quartz, it is yellow in color, and aventurine quartz, it contains a little bit mica or glistening scales of mica or hematite. And if it's the ferruginous quartzite, it is generally red or brown in color due to the presence of limonite or hematite. So that's why the name itself indicates that ferruginous quartzite. It contains iron. Then cat's eye. Cat's eye, it's a variety of the quartz. It's grayish or brownish in color, and it shows an opalescent structure. So opalescence phenomena. It is due to the inclusion of fibers, and it bears some fanciful resemblance to the cat's eye. And if you see tiger's eye, it's yellow-brown in color, and it's a pseudomorph after crocidolite. So crocidolite is a variety of asbestos. So coming to the uses of this, so rock crystal, amethyst, cat's eye, tiger's eye, and most of these minerals, like if you see smoky quartz, these are very, very extensively used in jewelry and for ornamental purposes. And because of its piezoelectric property, quartz is used in the electronics equipment. As we have discussed in the properties of minerals, electric property of physical properties of minerals, we have discussed that the quartz possesses piezoelectric property. And coming to the optical properties in thin section, so quartz is colorless and it is transparent, it is unaltered, and it shows no cleavage and weak birefringence. So and it exhibits gray to white interference colors because so quartz, it is uniaxially positive, and it has a low relief and little birefringence. Suppose if observed in thin sections and without the analyzer is installed, it is invariably colorless. And this is the most distinctive characters in how to identify in the thin section. It is typically it has a smooth and polished like surface texture. And how we can identify the quartz from the feldspars is, it's suppose quartz is a uniaxial positive, and if you see the feldspars, they are biaxial nature. And how we can identify quartz from the nepheline is, so it's a feldspathoid. So how we can identify from nepheline is, so nepheline is uniaxial negative, whereas the quartz is uniaxial positive. So though apatite, it's a phosphate mineral, though apatite has a similar birefringence as quartz, it is uniaxial negative and it has a very high relief, whereas quartz is uniaxially positive. So when normal quartz, it exhibits an elongated habit, it is elongated parallel to the c-axis, and thus the length in the it is slow in length. Then coming to the occurrence. So quartz occurs as an original constituent of more acidic igneous rocks, and also granites, quartz felsites, rhyolites, etc. Also from the bulk of the sandstones, that means how they result from the breaking of the igneous rocks containing quartz, and it is a common constituent of many metamorphic rocks also, and it occurs in siliceous igneous rocks such as volcanic rhyolite and plutonic granitic rocks. It is common in metamorphic rocks at all grades of metamorphism, and it is an important constituent of sand. So in most of the sands, or the chief constituent of sand is quartz. So because it is highly resistant to weathering or chemical weathering, it is found in a wide variety of sedimentary rocks as well. So several varieties of quartz can be found, but these are usually only distinguishable in hand specimen. So in the previous form, I have given in the table form. Here also the important varieties, you can check it like this: rock crystal, amethyst, rose quartz, smoky quartz, transparent quartz, milky quartz, citrine, and then aventurine quartz, ferruginous quartz, cat's eye, tiger's eye. All these are the important varieties. Coming to the cryptocrystalline variety of silica. This is also known as a chalcedonic silica. So here there are again types are there. Number 1, chalcedony, number 2, flint, and 3, jasper. So here chalcedony, that means depending upon the color, a number of varieties are recognized under chalcedony. So coming to carnelian. So A, that means first category, or you can say that carnelian. It is a, you can see here, it's a reddish or yellowish red variety. And another variety is sard. It is a brownish variety of chalcedony. So coming to another variety of chalcedony, that is known as a chrysoprase. So it is an apple green variety. So you can see that, so here the chrysoprase, it's an apple green variety of chalcedony. Coming to heliotrope. Heliotrope is a bright green in color, and with the small spots of, here you can see the spots of red jasper resembling similar like a blood drops of the blood. Because of this, it is also called as a bloodstone. So heliotrope is also known as a bloodstone. So another variety that is known as agate. So here it is a banded variety of chalcedony. So if the chalcedony is banded, that is known as agate. And when the bands indicate the successive stages of deposition, and these may be of different colors. See, you can see in the onyx, you can see the different colors. And the bands are generally in parallel wavy or irregular lines. And when the bands are parallel straight lines, then it is called as a onyx. The same banded nature is seen in agate, but when the banded nature is in straight lines, it is called as a onyx. All these are the cryptocrystalline variety or chalcedonic varieties. Coming to another variety that is known as a flint. So here it is gray or black in color, and it has a typical conchoidal fracture. And so you can see the hard stone and chert, these are also similar to the flint, but they possess the even fracture. Coming to the jasper, it is an impure opaque form of chalcedonic silica. It is generally different colors, like if you see red, brown or yellow in color, and rarely it is green in color. It is an opaque even in very thin sections. The another variety that is known as the amorphous variety of silica, that is known as the opal. So its chemical composition is SiO2 NH2O. It consists of water molecules. And the form, if you see, it exists in different forms like a compact, amorphous and reniform, like kidney form also. Color, it exhibits white, yellow, etc. And if you take the streak, it is uncolored. And coming to the luster, it has a partly or subvitreous luster, and fracture is conchoidal. And we can see the cleavage in this opal, that means absent, cleavage is absent, and hardness is 5.5 to 6.5, and it has a tenacity, brittle tenacity. And there are two varieties like precious opal and hyalite. So precious opal means it's a gem variety, it exhibiting opalescence, and it shows brilliant play of colors. So that's why it is so precious. So it's a precious opal. And another variety, it is known as a hyalite. It is a colorless, transparent and glassy variety. So two varieties of opal. So number one is precious opal and number two is hyalite. Thank you.